So this is a demonstration video number 3, I believe. The first one was interrupted, so I had to do it in two parts. So it's 1 and 1.2. I just uploaded number 2. I'm going to do number 3. So this speech is going to be about the demonstration or experimentation of for the sixth graders that are learning chemistry or doing actually chemistry. They're working in the chemistry lab. Some of them like it, some of them don't like it. So we pretend that I'm a chemistry teacher. Is being invited to this school to help kids see if they like it or not, doing some fun experiments. So the title is going to be, well, the experiment actually is going to be about exothermic reaction. And let's see if I can do the experiment one more time. So here we go. Good morning, students. My name is Professor Carlos Hernandez. I also teach sixth graders in the South St. Paul Middle School, and I teach chemistry. I heard by your teacher here present that some of you don't like actually working in the chemistry lab, doing some experiments, which is kind of curious because you are actually playing with some good ingredients and creating something else. So one of my students told me we're creating Frankenstein. So that's kind of funny. Just pretend that way that is something, something fun. You gotta be careful, of course, because you're gonna be dealing with some chemicals that can potentially harm or damage your skin, or no. But you wear the gloves, the safety goggles. Plus, your teacher is gonna be present, and that's gonna be help you out. So what are we doing today? Is actually something they call the toothpaste for elephants, or the elephant toothpaste. And you're wondering, like, what? So what are we doing actually? And that's the fun name, but the real name, or the scientific name here is going to be an exothermic reaction. Where the exothermic reaction is exothermic. So X means outside, thermic means heat. So which is what we're going to create heat in the outside. And for this demonstration, I have some ingredients here that we're going to use. We call it ingredients, right? That's what I call it, to make some of the elephant toothpaste or this exothermic reaction. But before we start, I want to explain what exothermic reaction is. The exothermic reaction, it can be, is like it takes heat or energy to the surroundings. Well, let's see an example of that. Now that we're in the fall time, it's cold outside, you see your friends coming over, your parents' friends coming over, or just as a family go outside in your backyard and have a bonfire. So you throw some wood in there, you light that on fire, and then the fire is there, and what it fills around is heat, and you keep yourself warm. That's an exothermic reaction. So the heat at the outside of the fire is keeping yourself warm. Another example that you can go probably at Walmart or Cut Food, Target, or any of those stores, you buy some hand warmers. Those little packages that you kind of squeeze really hard, and then you shake it, and then you put it inside your gloves or inside any parts of your body, your pants, your socks. I'll do it when I run, for example. Now in the fall, I use those, put them inside my gloves to keep my hands warm, nice and warm while I'm running. So that's another example of exothermic reaction. That these little packages have some chemistry elements inside. When you break and you shake and react one with each other, and they create heat. And that heat, it keeps your hands or your body parts warm. Another one that we have, another more, for example, like huge reaction, or example, the exothermic reaction, it can be, for example, when the launch of a space rocket, when they go into the sky. To the sky, and then you go to space. All the fire that you see coming out of the rockets from the bottom of the spacecraft, they takes that space propulsor all the way, to the space with so much force. All those plumes coming out, and the fire. Actually, there's a chemical reaction, really, the combustion. There's a chemical reaction. Those that they call it aluminum oxide. That's what it is, and that actually is creates heat in the surroundings. That's why nobody is standing really close to that, because it's super hot around when the rocket is launched. That's another exothermic reaction example. One more we can say, for example, when you see on TV or you see in the cartoons, like my kids probably when they're watching like Mickey Mouse or something like that, you see the conductor. So there's all trains, they're all locomotives. They have this huge oven with fire inside, and it's burning and super hot. Where they're shoveling coils, you see these black coils that are traveling there, shoveling there, shoveling there. And what that does is like the fire combusts the coils. You can say eat the coils, and the coils what they do is when they disappear, they create gas. This gas is the vapor, and this they use it in some pipes that goes around, which makes the locomotive go faster and faster and faster and faster and faster, for the wheels of the train go around and around faster every time, and then just go. So that's another thing of exothermic reaction. They use these coils to create some heat in the outside, which is the gas, and the gas goes into these pipes and makes the train go faster. So that's what some examples that we have, like really easy, nice examples that we have to tell you. Now the other way is the endothermic reaction. Endothermic reaction is like it takes the heat, from the outside to the inside. We can say probably just a nice one for photosynthesis, for example, that takes the heat from the sun into the leaves, and the leaves create photosynthesis. They create the plants, and now you can see the plants, the leaves changing colors, and that's part of the photosynthesis right there. Or our body, when we eat, we create ATP and use the energy to keep us going and keep us going and going. And so that's another example of endothermic reaction. But we don't want to do that. We want to do the fun part right now. Is here the exothermic reaction experiment. So what we have here is an empty bottle. It used to be orange juice, and we have hydrogen peroxide. Hydrogen peroxide. You can find it in any store or Cut Foods, any pharmacy. We're going to use the 3%, which is the weakest one. No, practically we can use the 6% volume concentration, but we're going to use this one for now. So we pour some in here. Oh, before anything, safety first. Use your goggles because we don't want to go blind or anything like that. So we put the goggles on, you can tell, and we pour some of this hydrogen peroxide inside. Hydrogen peroxide has an extra molecule of oxygen. It's H2O2. And we're going to throw everything in there. Now our ingredient is dish soap. We're going to throw some in there. That's to create the bubbles. We have some food colorant to color your cupcakes or your cookies, cinnamon cookies, all that stuff. You throw some good amount in there, like that. We cover it and we shake it. And we switch it like that, so it's nice and all mixed together. It's green now. So we open it again. And now, as I explained earlier, I have some paper towels here to clean up. As I explained earlier, we have the hydrogen peroxide. It has an extra molecule of oxygen. So what we want to do is we want the extra molecules out of it. So we need something that calls a catalyst. Catalyst in this case is going to be the yeast that help us to make bread. So it's a helper. They're going to take that extra molecule of oxygen out of it. So for that we have 1 teaspoon of it, and we're going to mix it with some hot water. And we mix it for a good 30 seconds. Good 30 seconds. I'm sorry, that so good 30 seconds right here. Make sure there's no crumbles around. It's all good mixed, and why not? So we do it. 30 seconds. This yeast is going to help us to take the oxygen out of it, and the oxygen molecules actually is going to go inside of the foam. So you will see that. Now we're gonna pour it into this hydrogen peroxide, soap, and food coloring. And here we go. There we got it. That's what you get. That's an exothermic reaction. We have our bubbles. As you can see, if you touch the bottle, it's nice and warm. So that's creating heat right there. We're creating heat, and that's what an exothermic reaction is. So thank you.